Friends, today I'm going to discuss about the topic application of geoinformatics in environmental management. First of all, I would like to talk about geoinformatics. Geoinformatics is a science and technology which develop and uses information science infrastructure to address the problems of geography, geoscience, and related branches of engineering. Otherwise, it is the art, science, or technology dealing with the acquisition, storage, processing, production, presentation, and dissemination of geoinformatics mission. The branches of geoinformatics include remote sensing, GIS, cartography, global navigation satellite systems, photogrammetry, and DBMS. Environmental management. As per Barrow 2005, environment management can be referred to as a goal or vision to attempt to steer a process to the application of a set of tools to a philosophical exercise seeking to establish new perspectives towards the environment and human societies and to much or more besides. Environment managers are a wide diverse group of people including academics, policymakers, NGO workers, company employees, civil servants, and a wide range of individuals or groups who make decisions about the use of natural resources such as fishers, farmers, pastoralists, etc. Introduction. Perhaps the most important concern for all of us today is the protecting the environment we live and breathe in, and climate change issues are creating havoc with erratic weather patterns affecting everything from crop production to untimely melting of ice glaciers. There is a lot to worry about, and immediate action is definitely required. It's not that the world has not geared up to take corrective action, but we have to do more. So therefore, geoinformatics can help us to achieve that. Geoinformatics is a powerful platform which enables every sector to perform better, and environment is no exception. Coupled with a digital map, GIST is a part of geoinformatics that allows a user to see location, events, features, and environmental changes than unprecedented clarity, showing layers upon layers of information, or in other words, we can say overlay analysis that helps. These layers consist of environmental trends, social stability, pesticide use, migration corridors, hazardous waste generators, the source points, lake remediation efforts, and uh, at risk water wells. All these layers can be undergo overlay analysis, and from that we will get a better result for environment management, or we can see the effects on environment or factors affecting the environment, and also we can take appropriate decisions to overcome or to protect the environment. The effective environmental practice considers the whole spectrum of environment. ArcGIS and other GIS technologies offers a wide range of analytical tools to meet the need for of many people and helping them make better decisions about the environment. People in the environment management community use GIS to organize existing information and communicate that information throughout their organization. This can be used as a strategic tool to automate process, transform environment management operation by garnering new knowledge and support decisions that make a profound difference on our environment. This is a map showing several thematic layers that is combined to get a better view of the total environmental factors that prevails in a geographical area that includes land and air quality, vegetation, and land use type maps, population density maps, and jurisdiction boundaries, urban development, land features, hydrographic data, etc. Now, GIS integrated environment management system includes all these factors. That includes environmental geodatabase that again consists of several other data sources, environmental mapping, production that includes thematic, temporal, and predictive mapping, and report products that includes compliance, compliance, impact plan, and notifications. And all this is connected with the internet that is provided. All this information is provided to the public sector and private sector and other organizations, interested organizations, to take proper measures to predict the factors affecting the environment, as well as to protect the environment by taking proper remedial measures. All these act in an integrated manner. So next one, ESRI is just tool for environment management. This also includes just a desktop GIS, that is ArcGIS, ArcInfo Editor, ArcView, all these things combined and develop a GIS. And GIS web services, lightweight viewers, web browsers, and mobile GIS, server GIS, and all these tier databases, DBMS. All these are connected as a network, and informations are shared, and therefore to take better decision for decision making process for environmental management. Now, the role of informatics in environment management: to ensure the accurate reporting with improved data collection, to improve decision making, increase productivity with the streamlined work process, provide better data analysis and presentation options, model dynamic environmental phenomena, create predictive scenarios for environmental impact studies, automate regulatory compliance process, and disseminate maps and share map data across the internet. Now, environmental impact assessment, EIA, the application of geoinformatics in EIA. The EIA is an important policy initiative to conserve natural resources and environment. Many human activities produce potential adverse environmental effects, which includes the construction and operation of highway, railway, roads, pipelines, airports, radioactive waste disposal. More environmental impact statements are usually required to contain specific information on magnitude and characteristics of environmental impact. EIA can be carried out effectively by the help of GIS by integrating various GIS layers, thematic layers. Assessment of natural features can be performed. Disaster management. Today, a well-developed geoinformatics systems are used to protect the environment. It has become an integrated, well-developed, and successful tool in disaster management and mitigatory activities. This can help with risk management and analysis by displaying which areas are likely to prone to natural or man-made disasters. When such disasters are identified, preventive measures can be developed. And these are GIS and maps in disaster management. That includes uh, rehabilitation, recovery, prevention and mitigation, relief, response, and prediction and warning. All this comes under GIS and maps in disaster management. All this can be incorporated with GIS. Now, management of natural resources. This helps in identifying the impact of human behavior on natural resources and lead to more effective utilization of the same. Data about natural resources could be collected to RS and aerial photography or satellite imagery, and then they are mapped using GIS technology. Major applications of GIS in natural resource management is in confronting the environmental issues like flood, landslide, soil erosion, drought, earthquake, habitat analysis, environmental assessment, pest or disease outbreak, impervious surface mapping, lake monitoring, hydrology, land use, land cover monitoring, mineral province, geomorphology, and geology. It also addresses the current problems of climate change, habitat loss, population growth, population pollution, etc., and provides information about land area change between time periods. Now, information obtained from GIS can help to study specific areas, and monitoring can be done in and around those areas. It provides relevant information about the environment condition and policy including conservation programs. Maps in GIS provides the information of location and current resources. The technology can also help in well management and maintenance of agriculture, water, and forest resources. Foresters can easily monitor forest condition. Agriculture management includes the managing of croplands, managing crop rotation, soil fertility, etc. And water is one of the most essential constituent of the environment. This is used to analyze geographic distribution of water resources. They are interrelated, that is, forest cover reduces the stormwater runoff, and the tree canopy stores approximately 215 triple zero tons carbon. This is also used in afforestation. Determination of land cover and land use. Application in the determination of land cover and land use. Land cover means the feature that is covering the barren surface. The land use means the area in the surface utilized for particular use. The role of GIS technology in land use land cover application is that we can determine the land use land cover changes in the different areas in various time periods, or within a pattern where, or just land use land cover change pattern within a time period. It enables to find out sudden changes in a land use land cover, either by natural forces or either by other activities, human activities like deforestation, etc. Soil mapping provides resource information about an area. It helps in understanding soil suitability for various land use activities. It's essential for preventing environmental deterioration associated with misuse of the land. This helps to identify soil types in an area and to delineate soil boundaries. It also used for the identification and classification of the soil. Soil map is definitely used by the farmers in developed countries to retain soil nutrient and earn maximum yield. Irrigation management. Water availability for irrigation purpose for any area is vital for crop production in that region. It needs to be properly and efficiently managed for the proper utilization of water. So these technologies helps to identify soil moisture, humidity, and also uh, quantify rainwater or precipitation, etc. Thereby, and also groundwater analysis or prediction of groundwater sources, etc. Air quality monitoring has become an important part of healthy living, and this can play a very important role here as well. This integrated platform by leveraging sensors and IoT, Internet of Things, for air quality monitoring, analytics and planning, can accurately predict the particulate matter levels in varied areas within the city. We know city is polluted and it consists of city air consists of particulate matters, and this when we analyze air quality, we usually look for particulate matter, particulate particles or particulate matter in the air. So it can also tell you which areas are the most hazardous or most dangerous for everyone, specifically for asthma patients. This analysis can help the field officers to take corrective action on time to improve the air quality. The citizen engagement is also becoming an important part of such application. Using mobile apps, and the citizen can also make the authorities aware which area need immediate action. Now, wetland mapping. Wetland contribute to healthy environment and retain water during dry periods. Thus, keep the water table high and relatively stable. During the flooding, they act to reduce flood levels and to trap suspended solids and attach nutrients. This provide options for wetland mapping and design projects for wetland conservation quickly with the help of this. Integration with remote sensing data helps to complete wetland mapping on various scales. We can create a wetland digital data bank with species information using this. Now, application in watershed management. Water as a resource has been diminishing over years. In Africa and other developing nations, the availability of clear water has been scarce. The water management has therefore become a challenge in developing nations. However, with the use of satellite data, water bodies such as rivers, lakes, dams, reservoirs can be mapped in 3D, like in 3D analysis tools. By using these tools, you can view these maps in 3D or view the feature or lakes or rivers in 3D model. So it helps in with the help of this technology. This data can be used in sustainable management of water bodies, since respective authorities can decide which region need effective protection and management. Now, at the same time, decision regarding the most effective means of utilization of these regions can always be arrived at. Application of this data in forest management. Over the last century, the forest cover of the uh, world has declined at an alarming rate. Being a renewable resource, forest cover can be regenerated through sustainable management. With the help of remote sensing engines, a forest manager can generate information with regard to forest cover, types of forest present within the area of the study, human encroachment in the forest land, protected area, encroachment of desert-like condition, and so on. And it also includes forest fires and also grazing data, and also cutting of looting of forest woods. All these things are also included. And now the information is critical in the development of forest management plans and in the process of decision making, to ensure that effective policies has been put in place to control and govern the manner in which forest resource is utilized. This is the picture of the above ground wood biomass of USA, and this is a map from NASA 2011. So I'm sorry because it's not clear. Actually, while editing, some problems happened. I'm, I'm sorry. Now, application of this data to combat desertification. Geospatial data can be used to determine the soil types present in the given area and the nutrient availability. So, negative change can always be identified once this data is collected over a long period of time. This data can also be used to determine the land use practices within a given area and the vegetation constitution and the impact that they have on the environment. Subsequently, stock formation of regions can also be determined with the use of this data. With all this information, an individual can easily determine whether desert-like conditions are encroaching in an area, and also we can estimate the soil moisture. Soil moisture content is very less, then also we can determine whether desertification is happening or not. If the desert-like conditions have been identified, the impact and the intensity shall be analyzed in order to decide on whether the artificial or natural methods shall be used to combat the situation. So this is the map. Actually, this map, sorry, I couldn't see the map clearly, but please let me look. Oh, this is a surface soil map at 1 kilometer resolution, retrieved from the Advanced Synthetic Aperture Radar instrument of ESS Envisat satellite, operating in global mode for Southern Africa Development Community region. The results were obtained from ESS Share project. So it consists of some colors, combination of yellow, dark brown, and blue and white, and that shows the intensity. The highest intensity is shown by dark blue color. That means soil moisture is high in dark blue color, and lowest moisture is shown in the dark brown color. Actually, here is red color is visible in this figure, so that represents the lowest moisture condition area. And agriculture mapping, technological innovations and geospatial technology helps in creating a dynamic and a competitive agriculture which is protective of the environment and capable of providing excellent nutrition to the people. These tools and online web resources are helping farmers to conduct forecasting and manage their agricultural production by utilizing multispectral imaging collected by satellites. The ability of the GIS to analyze and visualize agricultural environment and workflow has proven to be very beneficial to those involved in farming industry. This has the capacity or potential to analyze soil data, determine which crops should be planted where, and how to maintain soil nutrition so that the plants are best benefited. This in agriculture helps farmers to achieve increased protection and reduce cost by enabling better management of land resources. It also helps to identify diseases or diseased stages of plants by the reflectance from the plants, the NIR reflectance from the plants. The risk of marginalization and vulnerability of small and marginal farmers, who constitute about 85% of the farmers globally, also get reduced. Agriculture geographic information systems also using geoinformatics technology enables the farmers to map and project current and future fluctuation in the precipitation, temperature, crop output, etc. The farmers farming is getting smarter with the availability of advanced technologies like precision equipment, Internet of Things, sensors, actuators, geopositioning system, big data, unmanned aerial vehicles, robotics, and it also in web. We can also include interactive maps that includes diseases, several types of pests and pests found areas in a specific country or a specific state for a specific species of crop. So in that way, if everything is possible using this technology. Application of this data in biodiversity management. The geospatial data can be used in the management of flora and fauna within a protected area. Ground and aerial photographs, for instance, are essential in this practice. Aerial and satellite photographs can be used to determine the presence and distribution of vegetation within a protected area. These photos can also be used to determine the presence and distribution of invasive species within an ecosystem. This information is essential as it determines the amount of cover and food that is present, particularly for herbivores during various seasons of the year. Aerial photographs can be used to ease the process of counting during animal census activities. So aerial photographs that includes smaller areas than satellite imagery. So that is why animal census is applicable, and determining animal census um, uh, is suitable or can be done using aerial photographs. The stock capability of the photographs eases with this process. It is always essential for protected areas managers to determine the population and the distribution of various animal species within a protected area to ensure that they have enough food and water, to eliminate the chances of overstocking that might lead to soil erosion, and to ensure that a balance within the ecosystem is arrived. And also we can incorporate the GPS, so attach GPS within the body of these organisms so that we can count them. Geospatial data can also be used to show human encroachment into the protected areas as well as animal activities outside protected areas. This data is critically essential in the process of resolving human or wildlife conflict. Finally, the use of GPS technology can be applied, as I have told earlier, the movement of endangered species as well as nearly introduced species to determine their progress as well as protecting them from poachers. Finally, geospatial data can be used to carry out environmental impact assessment of various projects carried out within protected areas. Also, can conduct an EIA, or it can assist EIA. The projects such as building of roads, buildings, pipeways, dams, and so on might have various impact effect on flora and fauna of the ecosystem. The geospatial data has become essential in the biodiversity management. Zoning of landslides. Landslide hazard zone is the process of ranking different parts of an area according to the degrees of actual or potential hazard from landslide. The evaluation of landslide hazard is a complex task. It has become possible to effectively collect, manipulate, and integrate a variety of spatial data such as geological structures, surface cover, slope, characteristics of an area, which can be used for hazard zonation. Estimation of flood damage. This helps to document the need for federal disaster relief funds, which appropriate and can be utilized by insurance agencies to assist in assessing monetary value of property. The local government need to map flooding risk areas for evaluate the flood potential levels in the surrounding area, and also using GPS technology we can mark our areas safe. We are in a safe location, or we can show our area that we are not missing and we are safe. The damage can be well estimated and can be shown using digital maps. Identification of volcanic hazard. Volcanic hazard to human life and environment include hot avalanches, hot particles, gas clouds, lava flows, and flooding. Potential volcanic hazard zones can be recognized and characterized. Historical records of volcanic activities. It can incorporate witches and this thermal infrared uh, thermal sensors can be used to predict the volcanic activity, so that we can avoid volcanic hazards. And thus an impact assessment study on volcanic hazards leads with economic loss and loss of lives and property in densely populated areas. And this is the map showing total population of the area and the impact of volcanic activity in that place. Can the impact caused by the if the volcanic outbreak happens. Now, wildfire mitigation. Wildfire causes huge loss of flora and fauna. Every first strategy to defend the forest against the wildlife is to avoid the gas. Is to avoid it. The GIS has proved its potential in forest fire management. There are different applications of GIS in forest fire management, out of which the most important one are hazard map production, forest fire simulation, and resource management and species conservation. The simulation by itself has a main role in the management of forest fire. This uses various information layers such as digital elevation model and index of flammability, along with the different models for the purpose of forest fire, and also moisture content and humidity. All these data are also collected in order to determine forest fire. Now, forest fire hazard mitigation in Lebanon using remote sensing and GIS. Forest risk maps are given. First is vegetal cover, fuel type, slope gradient, fire occurrence map, evaporation, and slope aspects. All these maps are overlaid or undergone overlay analysis for the final results, for getting the final results. Now, case studies. Case study 1, the topic is GIS based forest fire risk assessment and mapping. Authors Chen Cheng Jai, Yang Kyo Yang, and Hong Yong Guel. Introduction. The forest fire is a usual disaster in the real life, causing huge life, property, and ecology losses. A risk assessment model is to identify, classify, and map forest fire risk areas in the present paper. The model considers three parts, that is the hazard identification, vulnerability analysis, emergency response capacity analysis. The first part concentrates on several influence factors in the forest fires, including land use, topography, meteorology, where the forest situate, the and where the forest situate. And the second part is made up of population density and value of forest resources, the forest fire response capacity, including forest fire brigade, watchtower, and helicopter water resource, is the third part. The proposed method in this article is scenario based and involves natural and human factors in each step. It implements and expands the analytical deliberate process. So this includes several flowcharts and maps and tables. So let's see the methodology flowchart: database and hazard identification, vulnerability analysis, emergency response capacity analysis. Hazard identification includes hazard inducing environment, and vulnerability analysis, population and economic values are given from for has been taken from vulnerability analysis. And emergency response capacity is again split given as emergency and rescue equipments. All this goes to this spatial analyst and forest fire risks, where verifying with ground data is incorporated. And finally, forest fire mapping zone. Now, forest risk in index. Forest fire mapping zone divided into three: fire hazards, vulnerability, emergency response capacity. Forest fire hazards includes land use, elevation, slope aspect, temperature, relative humidity, wind force. All these maps are included in fire hazards. And vulnerability includes population density, value of forest resources. Emergency response include forest fire brigade, watchtower, helicopter water resource. So this is the table showing the classification of forest hazard factors, and several values are provided for each based on their potential. So now there is a positive correlation between the speed of fire spread and temperature, wind force, and a negative correlation between the relative humidity. From analyzing this table, we can see positive correlation between speed of the fire, wind, temperature, etc., and negative correlation between relative humidity. Now this is the chart showing the classification of vulnerability factors, variables like population density, value of forest resources, and its classes. So it is divided into various classes and their values are given. As for the vulnerability factors, population density and the value of forest resources are considered. Human activity is one of the main causes of forest fires. When the population density is small, the forest fire usually is caused by natural forces such as lightning, spontaneous combustion, etc. When the population density is large, human activity becomes dominant. There are different interpretation of the value of forest resources. Broadly speaking, forest price is the monetary value of the forest performance that includes the stumpage values of forest and animals, plants, microorganisms, ecological benefits of forest. In a narrow sense, it is a monetary value of stumpage price. Now, for a certain region, forest fire risk is calculated with the data acquired and the weights for each factors based on the total condition, which is represented by the equation to determine the fire hazard model, and it's given here WXI, where R is the numerical, R is equal to sigma WIXI, where R is the numerical index of the forest fire risk value, xi is the value of the factors, and wi is the weight of the factors, which is determined by gray relativity and analysis described below. Weight of factors. The Gray relativity analysis is used to assess the degree of influence of each factor. Gray relation analysis is an effective technique that can be used to solve the uncertainty problems under the discrete data information incompleteness. So this is something, some extra informations are given. So let's skip that, because there is lot of things for each factors, like land use, elevation, and each one we give different values. This is the weight of factors. Weight is given for each factor: land use, elevations, slope, everything. And results: the hazard identification map. This is the hazard identification map. It indicates the forest fire risk factors involve land use, elevation, slope, aspect, temperature, relative humidity, and wind force that are informed using RG software. Hazard identification map is a combination of 7 forest fire risk factors through map algebra algorithm in order to reflect the risk of the forest fires in the region. Red area indicated the highest risk, and blue area shows the lowest risk. So now next one, here this is the vulnerability analysis map. So it is divided into 4 classes. So it is a combined of population density and the value of forest resources. It shows that the north area has greater vulnerability, mainly due to the higher value of forest resources. North area has the most vulnerability. North area, where red areas are shown, has the most vulnerability. It is due to the higher value of forest resources. So emergency response map is combined of distribution of forest fire brigade, watchtower, and helicopter water point. It is shown that the central area has poor emergency response, because there the risk or vulnerability is high. That is why there is a red color given, and mainly due to the distribution of watchtower. Mainly because of the distribution of watchtower, and then you can see distribution is mostly low in that area. So now the final map of forest risk zone map, it is a combined of hazard map, vulnerability map, and emergency response map in order to reflect the region's integrated risk. And it is clear from the figure that the northern map of the region has a higher risk of forest fire. We can see from the figure itself that that area is shown in red color, so there is the highest risk, and blue is the lowest risk area. Now case study 2. The topic is depicting the changes in the land surface cover in Al-Hassa Oasis of Saudi Arabia using remote sensing and GIS techniques. Authors Abdul Rahman and Abdul Halim. These are the authors. Introduction. Since the economic history of Al-Hassa Oasis is tightly associated with agricultural practices, where the oasis produces a considerable share of dates in the Kingdom of Saudi Arabia, this study aimed to depict the spatial variation in the oasis green cover using 2 scenarios corresponding to urban sprawl over past 32 years. Scenario first included the old oasis besides the surrounding cities, irrigation discharge lakes, and newly embedded agricultural areas over the southern part of the oasis, that is the new oasis. In this scenario, the quantitative share of the new agricultural areas that extended out of the old oasis, where the new extended agricultural areas were aimed at compensating the degraded agricultural land inside the old oasis, was studied. The scenario 2 was applied over the old oasis only in order to examine the actual change in the vegetation cover, that is degradation. within this oasis with respect to the other classes of surface cover throughout the estimated period, that is almost the last 30 years. Materials and methods. This is the study area map. The new oasis, old oasis, sand dunes, water lakes, date farms, residential area, bare soils, all these are represented in the given map. You can see it and you can understand it. Now, data collection and processing. 4 cloud-free satellite images from the Landsat series were acquired for the assessment period of from 1985 to 2017 with a spatial resolution of 30 meter and calibrated using data-specific utilities of NV software, where the image digital number was transformed into spectral radiance. Subsequently, reflectance images are generated from radiance pixels. Atmospheric correction tools such as dark object removal, haze removal, and cloud masking were used to correct the sensor radiance for atmospheric effects using fast line of sight atmosphere analysis of spectral hypercubes or flash. Now, image enhancement and linear histogram stretching were also performed, and these are actually we know how why to increase the clarity or pixel brightness and pixel clarity. We use image enhancement and linear histogram stretching methods. An extra atmospheric reflectance was applied using published post launch gain value in NV, which is a value that is multiplied by the pixel value to scale it into physically meaningful units of radiance. The L lambda was radiance was calculated using the calibration coefficient from the metadata of the acquired image. Hence, the reflectance value of the images were determined from the obtained radiance value. Image classification. Acquired images were processed using supervised classification and 5 basic class types. They were determined mainly vegetation cover, urban area, bare land, sand dunes, and water bodies. Water bodies are as a class was not included in the scenario, as no water body was located within the border of this scenario. Accuracy assessment. A confusion matrix is typically used as a numerical technique for portraying the accuracy of the classified image. It is set in a tabular form of demonstrate correspondence between the result of the classification process and a reference image. In order to generate a confusion matrix, ground truth data such as field observation documented with the GPS map information or details image are needed. So ground truth data is needed. GPS values, coordinate values, etc. are needed. Field data are also collected. Change detection in the pre-classification process, image differencing techniques was applied for each of the 2 images. This technique uses change detection statistics to provide a detailed tabulation of changes between the 2 classified images. The procedure of change detection, you can analyze it, you can go through it and understand it. There are several process for digital image processing, and also classification methods are also given. Final result is a change detection. Now, results from the figures 3 and 4 shows the resultant classification maps of the study area for the year of 1985, 1999, 2013 and 2017 obtained from the scenario 1 and 2 respectively. A clear spatial variability in the vegetation cover was observed in the scenario due to the compensation plans. So black color shows unclassified, but here we cannot see much black color, but red color shows the urban area, brown bare soil, sand dunes is represented by yellow, and vegetation cover is represented by green color. Okay, here also the same thing. This is based on the second scenario. The other one was based on the first scenario. This was the first scenario based image. This is a second scenario based image. Now this is a confusion matrix. The overall accuracies of the surface cover were found by to be 97.6%, 100%, 97.8%, and 98.7% for the urban area, vegetation cover, bare soil, and sand dune classes respectively. This indicates a high similarity between the classifiers and the predictors, especially for the year 1999. During the process of error evaluation, greater than 94% for both producers and user accuracies were achieved with the kappa coefficient of more than 0.96 for all classified images. This is the classification for images classified for scenario second. Classification statistics. The summary of statistics of the occurred area of each surface cover class hectares under scenario 1 and 2 throughout the analysis period, that is from 1985 to 2017, is represented in the tables 3 and 4. And the range value for each class was also produced as a difference between the early stage and the later stage in order to reveal the final state for each class. Therefore, the resulting ranges show that the urban area class produced the highest change in the surface area. Scenario 1 shows that sand dune class was the biggest and most dominant among the others. Scenario 1 shows that the area of the bare land class was the second highest, followed by the vegetation. The urban area that estimated at 4,597.02 hectares in 1985 reached about 20,562.21 hectares by 2017 due to the urban sprawl. The urban area expanded nearly 16,000 hectares over the other classes by the end of the analysis period. The class of the water bodies represented by the agricultural, drainage, water, evaporation lakes occupied only a small portion of the surface over the new oasis. Finally, it is worth to mention from the scenario of the new oasis that the areas of the sand dunes and the bare lands classes were the most dominant in the terms of area that reflects the area geographical identity, where the area of two classes represent together of the total area. The scenario 2 was applied in order to examine the actual change in the vegetation cover within the old oasis with respect to the other classes of the surface cover, that both sand dunes and bare soil classes masked most of the old oasis surface cover. The area of vegetation cover in the scenario 2 was third largest in the category among the other classes. The urban class showed an increasing trend throughout the study period from 1985 to 2017 in both the scenarios. A major part of the sprawl was occurred in the new oasis and was verified from figures 2 and 3. You can see if I find from this increase reflects the continuous increase in the population and the invasion to settle within the green spots alongside some other social and economic considerations. So this is the summary statistics for the occurred areas of each surface cover class by scenario. And this is a change detection happened in the time period from 1985 to 2017 as per the scenario 1 and scenario 2, and second also it's a combo. That's a combo of years, that is 1995, 1999, 1999, 2013, and 2013 to 2017. These are the classes utilized by urban, classes utilized by vegetation, so that this classified separately. Now case study 3. Topic: climate change vulnerability in the tropical region based on environmental and social economic factors. Authors Sarun Savit, Andrea Germandi, Sheila A.M. and Vinita P. That's our miss. Introduction. Sheila et al. Assessed in 2018 assessed a local dimension of vulnerability in the tropical state of Kerala, India, using a purposely developed vulnerability index which account for both environmental and socio-economic factors. The large extent of coastal wetlands and lagoons and high concentration of mangrove forests make the state environmentally vulnerable. Low human development index, large population of socially deprived groups which are dependent on the primary sector, and high population density make the state vulnerable from the socio-economic point of view. The present study investigates the climate change vulnerability at the district level in the state of Kerala, relying on purposely developed a composite vulnerability index and encompasses both socio-economic and environmental factors. So this is the study area. Whole Kerala is the study area, includes all the districts, 14 districts. Now, methodology. First methodology step deals with the identification of 9 key environmental and socio-economic variables covering important aspects related to climate change vulnerability in the context of Kerala. Lagoon, dense forest, shola forest, coastal wetlands, sand beaches are important vulnerable system and susceptible to the effect of cumulative stresses. The relative extent of this ecosystem was measured in each district. The economic, socio-economic variables, human development index, population dependent on primary sectors like agriculture and fisheries, etc. Socially deprived classes and population density has also been included. The weights are assigned to each indicator of every district based on the vulnerability importance to the particular phenomena as various reports, namely Census Reports 2011, State Environment Report, State Wetland Atlas, Human Development Report 2005, and State Economic Review. The Composite Climate Change Vulnerability Index was also tested by applying different normalization methods and using different weighing factors for the selected indicators. In the Environment Vulnerability Index, the ranking was given to each variable set 2, 4, 3, and 8 based on the degree of vulnerability, where 2 indicates the district with the least vulnerability and 8 with the very high vulnerability. The individual shares of the population density, population depending upon the primary sector and socially deprived classes have been calculated as percentages. Weighing for the socio-economic variables relied on expert judgment, where four variable shows most affected by climate change, that is the population density. The three variable shows the population dependent on the primary sector, and two variables shows economic socially deprived section, and one variable shows human development index. The socio-economic and economic environmental vulnerability indexes were developed by accumulating the corresponding values of each of the variables according to the separate district-wide maps of socio-economic and environmental vulnerability has been developed. So, the composite climate change vulnerability index has finally been developed using simple additive weighing for environmental and socio-economic vulnerability indices. Based on the composite vulnerability indices, 14 districts are clustered into 4 classes which are characterized by very high, medium, and low vulnerability. In order to confirm the above results, cluster analysis was conducted using SPSS software. Classification of districts has been done using cluster analysis, and Euclidean distance method and Watt's method were also used for the analysis for the accuracy assessment. Now these are the results, the physiography and land use in the different district of Kerala. And this is a southwest and a northwest monsoon rainfall at the Kotamparamba since 1980. This is historical data, that means already collected data. And onset of Indian summer monsoon from 1870 to 2009. That's from the Kerala State Action Plan on Climate Change 2014 data. And historic sea level rise in Kochi coast, and the other one is The table shows the assessment of weights for several environmental factors like coastal wetlands, lagoons, beaches, dense forest, mangrove forest, shoal, etc. And environmental vulnerability index table is given for each uh, coastal shores, lagoons, beaches, dense forests, mangrove, shoal, etc. So now the map of environmental vulnerability index map is given. Highest vulnerability is to lowest vulnerability is given, and highest vulnerability is shown given at Idiki. Now this is the socio-economic vulnerability index table, and that includes population density in personally deprived groups, primary, STISV, etc. And this is a socio-economic vulnerability map. There also you can see very high vulnerability index is in Idiki. A composite vulnerability index. This is a table, and this is the composite vulnerability index map. So you can see the high and low value areas or districts. So this is a composite vulnerability index. This is the cumulative one where all are combined. It includes very high vulnerable, high vulnerable, medium vulnerable, and low vulnerable. The ranges and the districts where we could are arranged based on the vulnerability, or are placed in the placed in uh, appropriate ranges. The cluster analysis by dendrogram, represented by dendrogram. Cluster 1 includes very high vulnerable districts, and cluster 2 very high vulnerability districts, and cluster 3 high vulnerability districts. Cluster 1 includes a very high vulnerability districts due to high population of primary sectors and socially deprived sectors. And cluster 2 includes very high vulnerability due to high population density, large extent of coastal wetlands and lagoons. And cluster 3 includes very high vulnerability districts that due to large extent of mangrove forest and sands. Cluster 5 includes districts with higher vulnerability due to comparatively large extent of coastal wetlands and medium population of primary sectors, and due to high human development index. And cluster 6 includes medium vulnerability districts due to population density, extent of beach and dense forest. Clusters 7 includes district with less vulnerability due to absence of shola forest and mangrove forest, and also due to the less extent of coastal wetland system. From this itself we can understand that if the ecosystem wetland system size or extent is high, then the vulnerability risk is also high. If it's low, then the vulnerability is also low. The cluster map showing vulnerability. This is a cluster map. Now conclusion. Among the 14 districts that makes up the state, the coastal district of Alapura is found to be the most highly vulnerable because of the high population density, very high exposed to coastal plain, physiographic region like wetland, lagoons and sandy beaches, which are exposed to the anticipated climate changes. Backwater banks and filtration ponds, paddy fields are the other sectors of coastal zones, because there is a high coastal zone is very high at Alapura region, and which are highly susceptible to sea level rise, which are predominant geographical particularities in the district. And the hilly district of Idukki and Wayanad and Palakkad have similar environmental and social characteristics, such as high dependence of primary sector deprived classes and low performance of human development index, and high concentration of forest density and shola forest. And there is an increase in the temperature across the highland region and a change in the distribution of the rainfall in the Palakkad district. A compensating vulnerability index based on the environmental and socio-economic factors revealed that higher percentage of population relying on agriculture related activities and social deprivation groups and comparatively low performance in the human development index and the existence of coastal lagoons, mangrove forests and beaches make the region highly vulnerable. The climate change vulnerability risk is highest in coastal areas. So climate change risk is very high in coastal areas. The general conclusion shows us the overall conclusion is of the seminar, which shows the with the rising pressure on the use of natural resources due to the increasing human population, geoinformatics can be used to manage the precious limited resources in an effective and efficient manner. Geospatial information is quite useful in the identification and analysis of factors that affect the utilization of these resources. Hence, a detailed understanding of these factors, sound decision could be reached in order to ensure the sustainable use of natural resources to meet the need of the current as well as future generations. These are the references. Thank you.